Hi, welcome to today's ATTIS webinar entitled Delivering Targeted Alerts, Advancing the Wireless Emergency Alerts 3.0 System. I'm Steve Barclay, Senior Director of Global Standards Development with ATTIS, and I am today's moderator. Before we begin, let me remind you that the webinar is being recorded for future playback. All participants are muted by default and placed in listen-only mode. Should you have any questions, please submit those via the online chat function. We will hold all questions until the end of the presentations, and we'll try to address as many of your questions as possible. In addition, slides will be distributed shortly after the completion of the webinar to all registered participants, and a recording of the webinar will be made available online. Before we begin with the presentations, I would like to introduce our speakers. Terry Brooks, Principal Engineer, Systems Architecture of T-Mobile. Terry's current focus includes regulatory topics in ATTIS, as well as 3GPP Services and System Aspects Technical Group. She's been involved in public safety and lawful intercept work in U.S. standards since 1994, holding leadership positions in joint ATTIS standards activities and participating in related scissor groups. Terry's been participating in the development of 5G specifications in various 3GPP technical groups and is currently chairing the GSMA 5G SI Task Force. Also, Brian Daly, Assistant Vice President, Standards and Industry Alliances with AT&T. Brian is responsible for AT&T standards and industry alliances. Some of its focuses include public safety initiatives, including mission-critical services for FirstNet, earthquake early warning and wireless emergency alerts, emerging technologies for 5G beyond, and national security emergency preparedness, just to name a few. Brian is responsible for managing AT&T's leadership in global standards and is a leading contributor to ATTIS's initiatives. His leadership is also reflected in the FCC CISRIC and TAC groups and the White House National Science Foundation Advanced Wireless Platforms Research Initiative. Terry and Brian, thank you for joining us today. A brief agenda for today's webinar is as follows. We will provide a summary of the scope of today's webinar, as well as a brief overview of ATTIS. Brian will overview the regulatory landscape and later provide closing remarks. And Terry will outline the 3.0, we have 3.0 capabilities, and in closing, we should have time for some questions and answers as well. In May, ATTIS published the 4 initial critical WEEE standards for 3.0 in support of FCC's second report and order on WEEE. These standards are for use by commercial mobile service providers, federal alert gateway providers, infrastructure vendors, operating system providers, OEMs, and chipset manufacturers in developing an end-to-end WEEE 3.0 system. ATTIS and its members were engaged with public safety, including FEMA, DHS, and National Weather Service, to name a few, during the development of these standards, and collaborated to address issues expressed by public safety and other key stakeholders. Today's webinar provides an overview of the WEEE 3.0 enhancements, including device-based geofencing. However, anything regarding when the service will be available, handset deployment, carrier deployment, or vendor information timelines, etc., is outside the scope of ATTIS and this webinar. So just a brief word about ATTIS for those of you who may be unfamiliar. We are a technology and solutions development organization with nearly 200 companies actively participating in our industry forums. ATTIS brings together the top global ICT companies to advance the industry's most pressing business priorities. Membership is open to ICT stakeholders, including public safety, and we have public safety members currently engaged in our emergency services activities. ATTIS is accredited by the American National Standards Institute and is the North American partner for 3GPP. ATTIS's partnership in 3GPP allows for coordination among ATTIS members to represent not only business needs, but also requirements for the North American region. ATTIS brings a wide array of expertise and experience by its members and staff to the various subject matters we address, including IoT, numbering, 5G, and the focus of today's webinar, emergency communications. Under this umbrella, ATTIS is addressing topics including location accuracy, next generation 911, SMS to 911, real-time text for emergency services, and more. And finally, just a brief overview of ATTIS's engagement with WEEE. ATTIS has been engaged since the inception of WEEE, previously called the Commercial Mobile Alert System, including participating in the FCC's advisory committee that was established in 2006. When the FCC released the original WEEE mandates, ATTIS converted those into technical requirements and standards needed to originally stand up a WEEE system. Subsequently, we continue to perform the same analysis to develop the technical criteria and standards required to implement WEEE enhancements. Below is a short summary of the various topics that have been standardized in ATTIS over the years. In addition, ATTIS has held frequent meetings with FCC staff to provide updates on progress and technical details on the solutions being developed. Lastly, in an effort to ensure the globalization of the standardized WEEE solution, ATTIS members submit contributions into 3GPP to ensure support for WEEE in the broader global public warning system. Now I'd like to turn the presentation over to Brian Daly of AT&T, who will dive into the regulatory overview of WEEE. Brian?
Okay, thank you, Steve. So yeah, what I would like to do is just briefly take us back and go through the various regulatory framework that defined what Steve mentioned was originally known as the Commercial Mobile Alert Service, or CMAS, but is now known as the Wireless Emergency Alerts, or WEEE. Next slide, Steve. So back in 2006, Congress passed the Warning, Alert, and Response Network, or WARN Act, which really started this WEEE Commercial Mobile Alert System effort. As part of that act, the FCC was directed to create what was known as the Commercial Mobile Service Alert Advisory Committee, or CMSAC, and several members of ATTIS, as Steve mentioned, and participants in today's WEEE enhancements were members of that CMSAC, and actually have been in the development of wireless emergency alerts since the 2006 timeframe when the CMSAC was created. The purpose of this was to establish standards, protocols, procedures, and other technical requirements to make commercial mobile alert service a reality. And the report, which you see the cover on this slide, was completed in September of 2007, and that report defined WEEE's basic system architecture and established the basic technical standards and operating procedures, which were fed back to the FCC and resulted in the initial rules for the Commercial Mobile Alert Service, or WEEE. Next slide. So WEEE 1.0 was created as part of an FCC rulemaking back in the 2008 timeframe. This initial rulemaking created three classes of alerts: the presidential alert, the imminent threat alert, and the AMBER alert, or child abduction emergency. And some of the characteristics that were established at that time, including not exceeding 90 characters of alphanumeric text, prohibition of embedded references, and the geo-targeting at that point was to an area not larger than the provider's approximation of coverage of the county or county equivalents. Now that, certainly was one area that it was immediately targeted for improvement, and the term "not larger" is important there, because many carriers actually did geo-targeting based on what was available in cell broadcast at that time. There was also a unique sound and vibration cadence that we're all familiar with, that those that are familiar with WEEE have heard. So this first report and order created the need for a standards effort, and ATTIS completed the WEEE 1.0 standards between 2009 and 2011. And in 2012, we saw the first deployments of WEEE. Next slide. WEEE 2.0 is the next round that the FCC had suggested enhancements for, and this included increasing the message length from 90 to 360 characters, establishment of a new alert message class for public safety messages, supporting embedded references in the actual message itself, as well as supporting Spanish language alert messages and state and local WEEE testing. ATTIS completed those standards between 2017 and 2018, and these are known as the WEEE 2.0 standards. Next slide. And now moving on to WEEE 3.0. As Steve mentioned, these standards were published in May of this year, the essential standards required to support the essential capabilities of WEEE 3.0, with additional standards in progress. What this includes is narrowing the geo-targeting requirements, and this is where we get to delivering the alert message that's specified by a circle or polygon to an area that matches it, and within a tenth of a mile of overshoot. It also has some rules for alert message preservation keeping the message around in a consumer accessible format and location for at least 24 hours or until deleted by the subscriber. Next slide. WEEE has a large number of standards, as you're seeing here, and these standards are required for several things. First, of course, is to meet the FCC rules. We have to define how the basic operation is going to work on the network, the interfaces with FEMA's IPause gateway, the broadcast, and the mobile device behavior. They all have to comply with the FCC rules. We also need consistency of operation. So when you have interfaces between FEMA and multiple carriers, when you have devices that have to work on any network, you have to have some level of consistency of operation across those networks and the ability to deliver those alerts to different carriers. So consistency is important. And finally, support for interoperability and roaming. The networks have to interoperate. We have to be able to support handsets that may roam onto different networks. So standards and standards dependencies are very important when we look at wireless emergency alerts, because we want to be able to have consistency of delivering these messages no matter what devices you're on, what network you're on, and making sure that we support the public safety mission. Next slide. So from the regulatory timeline, we talked about some of this already. WEEE 1.0 went live in April of 2012 with the National Weather Services delivering WEEE messages starting in June of 2012. And all the major carriers are participating in WEEE on a voluntary basis starting at that time frame. WEEE 2.0 was targeted in the FCC rules for May 2019, and that deployment and operation is currently waiting for FEMA implementation and IPause. And WEEE 3.0 is specified by the FCC rules for a November 2019 timeframe. Next slide. As mentioned, we are a part of FEMA IPause. FEMA IPause is the Integrated Public Alert and Warning System, which is a DHS-sponsored program to improve public alert and warning. It is a system of warning systems, both includes the current systems such as EAS and wireless emergency alerts, as well as the potential for adding new systems in the future. This chart is just meant to show that wireless emergency alerts is a component of FEMA IPause and this national system for local alerting, and it's just one of the many components available to emergency managers and alert originators for delivery of alert messages. Next slide. So at this point, I would like to turn it over to Terry to talk about some of the WEEE 3.0 capabilities. Terry?
Thank you, Brian. So Brian and Steve have both touched on the WEEE 3.0 capabilities in the FCC RNO, and what we like to do now is take a closer look at those capabilities, specifically in terms of what do they mean to the alert originators and what are the impacts to the network and the mobile devices. So we've said that mobile devices must be capable of performing device-based geofencing. And looking a little more closely, what does that mean? It means that they, for one, need to be able to receive coordinates that the alert originators have sent that define a shape. This can be a circle or a polygon. They also need to have the capability to use that information, compare it against their current location, and decide whether or not they need to present an alert. So multiple capabilities taken into account within the mobile device. Also, we have the 24-hour retention of the alert, as Brian had mentioned. The mobile must be able to recall that information for the user, so that needs to be stored and available for that period of time. While these capabilities stated focus on the mobile device, they actually do have end-to-end impacts and implications throughout the WEEE system. So on this next slide, what we're going to be looking at now is we've divided the presentation in two parts. The first part is going to be looking at that end-to-end flow from the alert originator all the way to the mobile device. We'll take a look at the information that the alert originator sends to define the alert area and how that is conveyed to the mobile device. We'll compare what we have in WEEE 2.0, which is network-based geotargeting, versus what we have in 3.0, where we have not only that building block, but then we also have device-based geofencing. And we'll discuss the control that the alert originator has over the use of device-based geofencing. So on the next slide, we'll take a look at the end-to-end alert flow. And once again, you've seen more complicated pictures of all of the different entities that can be involved in this, but this is just a simplified picture looking at this end-to-end chain of information. So we start with an alert originator, we go to FEMA, we start to come into the carrier's network. As you can see at the top of this diagram, I've labeled where ATIS and 3GPP specifications take over, which is that interface we call the C interface in between FEMA and our CMSP gateway. Just because we have this bracket around those particular areas of the network does not mean, of course, that there are not implications that come back to the alert originators at FEMA, and we'll also touch on those as well during this portion of the presentation. Something to note at the bottom of this figure, this is trying to indicate where we have modifications to the information that's coming from the alert originators. When this initially comes into the carrier's network, we have an alert that has both English and Spanish included now for WEEE 2.0. But when this comes into the carrier's network, these are broken up into one complete alert per language. They don't travel together as that full set of information. So we're actually duplicating all of the additional alert information that goes with that alert, and then we'll have an English alert go out and a Spanish alert that travels through the network. This becomes especially important as we go over the air interface, because this means that we're broadcasting one alert per language. That's including all alert information, all of the characters that go with the alert content. It's also including the coordinates each time that goes over the broadcast channel. So as we go on to the next slide, we need to take note that this duplication of the information that we just discussed on a per language basis brings us to the purpose behind some of what we have information on this slide. Each alert is going to be limited to a maximum of 10 geographic shapes. And once again, those are circles and polygons, so a maximum of 10 combined for those, and may contain a total of between 1 and 100 coordinates for those geometric shapes. I have some examples here, 10 polygons, each having 10 vertices, 1 polygon with 100. So any combination of these, circle in particular, circles only take up 1 coordinate because it's one vertex that is specified. But each of these examples is just to give you an idea of what could be contained in the alert. Each of them actually adds up to 100 vertices. Of course, you could have fewer than that, but we're specifically looking at that maximum of 100. Once again, going back, the figure that we just spoke about, each one of these goes over per language over the broadcast. So that's why we're setting these limits in place. It's basically reducing the possibility of broadcast channel overload, especially during a crisis when we have multiple alerts going at the same time in one broadcast area. It also reduces latency on the alert presentation, and this has to do with that timing for communicating the coordinates over the broadcast, as well as when the mobile is comparing its location against the number of shapes that are sent. So as we move to the next slide, we'll now take a look at the difference between, as I mentioned, the network-based geotargeting, which we have as a building block because we had that in place for WEEE 2.0. So that was our starting point for WEEE 3.0, where we're trying to then lend support to the device-based geofencing. So this is to clarify what the difference is in the field, what the expectation should be as we change from WEEE 2.0 to WEEE 3.0. As you can see, we have our geometric shape here, a polygon in the field. We have cell sites represented here, and as we all know, cell sites are not this uniform in the field in terms of their coverage, but it's just to give you an overview of what could happen in the field. So cell sites A through F for this particular shape, because they're all touched by that shape, whether they're covered by it or just a portion of the cell site coverage, they will all broadcast this alert based on that polygon shape. Now, for network-based geotargeting, for WEEE 2.0, without device-based geosensing, we will see both the red mobiles and the gray mobiles all presenting the alert. When we tighten that alert and the presentation by adding device-based geosensing, what we'll see is only the red mobiles presenting the alert, because the gray mobiles are not going to be comparing and looking at that polygon. So, pardon me, they will be comparing against the polygon. They'll determine the fact that they are outside the polygon, and they will not present the alert at that time. And then cell site G is just in here, for example, basically because this polygon does not touch cell site G, we will not actually send the alert to the black mobile. So before we go on, I wanted to talk about what the addition of the DBGF adds in terms with regard to restricting presentation, and the fact that only the mobile devices in the alert area, will be
Sarah, did you need us to go to the previous slide?
I'm sorry. I'm sorry. My audio dropped for just a moment there. My apologies. Having a little bit of audio trouble here. So anyway, no, the slide that you're on is fine. I had actually just started talking about it. I did not realize the audio had difficulties there. So for the alert originator control over device-based geofencing, what the FCC RNO has indicated to us is that when a geometric shape is sent from the alert originator, that we will actually perform device-based geofencing. However, if you look at WEEE 2.0, where the alert originator was able to send a geometric shape, and they were able to have that tightening of control over which cell sites were used for the broadcast, there are certain types of alerts that could benefit from the network-based geotargeting, but do not want the possible delays that we talked about with device-based geofencing. So as I mentioned earlier, we have some latency issues that are associated with device-based geofencing. These are not extreme latency issues, but when we're talking about possible even seconds of delay based on a broadcast, based on the comparing of the shapes, these can be critical seconds when you're referring to something like early earthquake warning system. So what we wanted to do was to supply a way for the alert originators to actually have the option to rely on just the WEEE 2.0 network-based targeting without bringing in a device-based geofencing if it's either critical due to latency, or if that type of tight targeting is simply not needed for the type of alert. So what we have supplied is what we call the device-based geofencing bypass. This is going to be an indicator that the alert originator can send to our network. When that indicator is received, device-based geofencing will not be performed. Now, one thing to note about this bypass, this indicator is not currently supported by the FCC report and order. We are in discussions, and I know that we've heard from some of the attendees to our meetings that they are in discussions with the FCC concerning the bypass and attempting to get support for that. But at this time, the bypass will not be recognized in the carrier's network until we have further clarification from the FCC, and they are supporting that functionality. Okay, so at this point, we've actually looked at the end-to-end network, what we see as input from the alert originator, what they should have in terms of expectations of what happens in the field based on those inputs. And now I'd like to move on to, we have an identified case in the field where the normal expectations of what should happen in terms of the alert presentation are not going to be met. So having identified that scenario, which many of you should have heard of as the roaming scenario, we'll now take a look at the WEEE 2.0 building block. Once again, we started with WEEE 2.0, we're building WEEE 3.0 on top of it. So we'll take a look at that particular building block. We'll also take a look at the roaming scenario itself. This will be the events that lead up to this situation in the field. We'll take a look at the roaming solution, and we'll also look at the potential impacts of the roaming solution. So moving on to the next slide. So alert presentation handling. This is broken into a two-step process. And once again, this is what's in place for earlier generations of WEEE. So in the mobile, we have the first step which is what we call duplication detection. This is when the mobile device, as it receives the alert, determines whether or not it's seen this alert before. And if it has actually seen this alert, then it will discard the alert. It won't pass it on for further processing. If it is a new alert, it has not been seen before by that mobile device, then it will be passed on to what we refer to as presentation processing. So in presentation processing, we have multiple checks that are performed. We have the presentation processing level, we perform WEEE 2.0 checks first. So this will be the opt-in and opt-out. This will be the language checks because we have both English and Spanish. So we do these checks first because they are just the normal processing checks that we do at that level. The next step beyond that would be to go into the WEEE 3.0 processing. So if coordinates have actually been received at the mobile, meaning that it's supposed to perform device-based geofencing, the mobile is going to then acquire its location, its current location. It's going to compare against those coordinates, taking into account the FCC allowed 0.1 mile overshoot, and then determine whether or not it needs to present the alert. If the location information cannot be obtained, and this is a very important point, we all know that at some times location acquisition can fail in the field. If that fails, then we are defaulting back to WEEE 2.0 functionality, which means that we just go ahead and present. This is based on the fact that we are specifically broadcasting in the cells which are pertinent to the polygon that was sent from the alert originators. And it was felt that it was better to go ahead and present the alert rather than risk not presenting the alert to a mobile device that might be within that polygon shape. Once the alert is either presented or not presented, it will be stored for that 24 hours for further recall by the user. Okay, moving on to the next slide. Okay, this is a figure just to help further explain what we're seeing happen in the mobile. I've mentioned that it's a two-step process. And we have our two different steps in here as we see the alert coming into the mobile device. Once we receive the alert, you'll notice this section is labeled duplication detection. This is where we either decide that this is a brand new alert and we pass it on for presentation processing, or we decide that we've seen this alert before and we're going to discard it. So once we move over to presentation processing for a new alert, we see the check for the WEEE 2.0 user settings. And once again, this is opt-in, opt-out, and language. If we pass those checks, in other words, we've got a match, we are actually supposed to present the alert based on those particular settings, then we'll move forward to say, did we receive coordinates? If the answer to that is yes, we're going to compare against current location and determine whether or not we present. So if we have a location match, that presentation will occur. If coordinates were not received, that means we're not doing device-based geofencing. We're not going to perform that function this time, so we will go ahead and present. Once again, underneath this figure, you see that we have noted that if the device's location cannot be obtained for comparison, then default action is to go ahead and present the alert. Okay, moving on to the next slide. So we've all heard about the roving scenario, the concern in the field where we have a series of events that take place and we don't have the result that was originally intended with alert presentation. So what we have here is a mobile device that receives the broadcast but is outside of the polygon, so it's going to compare its location. We're assuming in this case that DBGF is supposed to be performed. It won't present, but then later, as it starts to move into the polygon, thank you. So at this point, the mobile device is in the polygon, and if the alert is still active, it should receive a rebroadcast of that alert. At this point, because the mobile has moved into the polygon, we would expect to see the presentation of that alert. Instead, the duplication detection that we just discussed is going to receive that alert. It's going to recognize the alert as something that it has seen before, and it's going to discard it. It's not going to pass it on to the presentation processing. So even though the mobile has moved into the alert is still active, we don't actually see that presentation. And this was a concern. Obviously, we had already addressed WEEE 3.0 in terms of the functionality stated by the FCC, but we then needed to solve this particular case in the field. So ATIS performed an in-depth analysis on 17 proposed solutions from across the industry, attempting to solve this problem. Considerations taken into account at that time: backwards compatibility, whether or not it was going to further impact international standards, which of course always delays the standards process. Many different considerations that had to be taken into account while we were trying to analyze and choose one of these solutions. So the final solution chosen, which we refer to as the roving solution here, what this does is it actually allows the network, based on operator policy, to direct the mobile to reprocess an existing alert. And it does this by basically bypassing our duplication detection problem. So it's just a directive to the mobile. This is still a living alert. It's an alert that's still in process at the time. And it can specify a very specifically one alert, or it can do it with multiple alerts. But any existing alert, it can say, please reprocess this, look at your location again, and present the alert if needed. And moving to the next slide. There we go. Okay, so potential impacts of the roving solution. As we mentioned before, we have the duplication detection in place to keep alerts from going to the processing, presentation processing, if they had already been seen before. The purpose behind this, really, for the initial architecture of the WEEE solution, was that every time that we start that presentation processing, it's a more significant impact on the battery than we have in step one during duplication detection. So we're trying to protect the mobile's battery life. It's also a step in making sure that we don't present the same alert more than one time. So what we had to do with the roving solution, where we actually bypass that duplication detection, it means that we're waking up that presentation processing step more often in the mobile. And this can have impacts on battery life. So something to specifically note about this solution is that the roving solution wakes up all mobile devices within the cells that this is being broadcast in. So this is not just involving the mobiles that did not previously present. This is actually waking up every mobile and every cell site that we are broadcasting to. So right now, because of these impacts, and we do realize the importance certainly of having the roving solution there, we will be analyzing in ATIS different proposals on trying to balance the frequency or the need for use of the roving solution against the possible negative impacts to the user's battery power. So that's still under study for now. Okay, so now we've looked at two different areas. We've looked at the end-to-end flow of information. What can the alert originators put into the system in terms of the bypass, the coordinates, what should they expect to happen at the far end? We've looked at the roving scenario, which was the one case where the events in the field lead to something we would not want happening in terms of the alert presentation, and we've looked at the solution for that problem. What we're looking at now is the list of ATIS standards that have actually been completed. They were completed in May 2019. I think it was, as Steve mentioned, these were the 4 critical standards for the development and getting WEEE out to the field. If we look at the next slide, we have the ATIS WEEE 3.0 standards that are still in progress. These will be worked on in order of priority based on the information that we need, once again, for operations in the field. Not necessarily the critical development, but policy decisions, the roving solution, et cetera, that we discussed, some of those options for frequency of use and best practices for alert originators, operators, et cetera. So now to give the closing remarks, Brian.
Okay, thanks, Terry. So if we move to the next slide, we'll just close the webinar before the Q&A session with some points just to make sure that we bring out. First off, as Terry went through the discussion of the technical aspects, it's clear that enhancements to WEEE are dependent both on the network as well as mobile device deployments. And that also is going to require FEMA IPause changes as well as alert origination software to support WEEE 3.0. Now, many of the capabilities are in the mobile device. So there's a lot of dependency on WEEE 3.0 mobile device deployment. And those mobile device deployments are going to follow normal consumer device life cycles. The question always comes up on software upgradability to WEEE 3.0. That is still being analyzed by handset OEMs to determine if there will be any devices or what devices will be software upgradable. With that, now once deployed in the network, the enhancements that we're going to have with WEEE 3.0 are going to take time to fully realize. That is, over time, as new devices with the WEEE 3.0 capabilities are deployed and upgrades made to existing devices that are capable of being software upgraded, the enhancements will be observable. But again, that's going to take time to fully realize as devices are deployed into the field that have the capabilities for device-based geofencing. There's a need for alert originator outreach to understand those device dependencies, understand the polygon limits, understand latency, as well as how the roving solution works. And also for consumers, with device-based geofencing and location, one important point is that WEEE is not tracking any device, so there is privacy of users' location. It's not tracked anywhere. It's not actually in the system at all. It's really all in the mobile device itself. And as Terry mentioned, possible battery life impacts, which we're still evaluating and looking at as an industry. Next slide, please. What makes WEEE successful? It is a public-private partnership with one common goal of enhancing public safety. Having this public-private partnership extend into the standards process is very important because it allows us to make sure that we incorporate as many of the design issues into the standards as they're being developed. As mentioned, the standards-based solution is needed for consistency across wireless carriers and devices. And the cell broadcast solution that we have is available in the majority of handsets. And one of the benefits of WEEE is there's no need to download an app. It comes native in the device itself. And to make WEEE successful, we need to make sure we have that outreach and also continue the use of WEEE, whether it be to consumers to understand what WEEE capabilities are, or more important, to alert originators to make sure it's used in times of imminent threat, emergencies, and other public safety related topics. So with that, next slide, Steve. We'll move to the Q&A session.
Okay, great. Thank you, Brian. So we are at the Q&A portion of the webinar. We do have a couple of questions that have come in, and let me pull those up. So the first one, I'll say, Brian, this was probably targeted to you. Does the mobile device language setting determine the language, e.g. Spanish, of the alert received?
Okay, yeah, thanks, Steve. So with WEEE, all the information is being broadcast on the control channel, and that includes the alert messages in the various languages, English and Spanish, as well as the information required for device-based geofencing. This information is received in the mobile device, and as far as presentation of Spanish language, if the user has their setting to have Spanish alerts be presented, then the device will display those in addition to English. Now, the reason both are is that the interpretation of the FCC rules is English is mandatory and always must be presented, and Spanish, if the user has the setting set and it's broadcast and received in the device, then Spanish will be presented as well. Thank you, Steve.
Okay, thank you, Brian. We have slow ones coming in here. Terry, I think this one might be toward you. With WEEE 3.0 and 2.0 alerts having multiple languages, geo-targeting ability, WAN messages, and possible multiple active alerts, what is the expected time increase for the message display on the phone when taking all those factors into consideration, and what thought has been given to paging channel congestion?
Okay, thank you, Steve. In terms of message display, any kind of a delay there, remember, with all of those things going, I noticed somebody mentioned the WAM message. So just to clarify, because I did not bring up that specific name in my presentation, but that's the message that's the message name that we gave to the roving solution, where the network is directing the mobile to reprocess. So in terms of the actual display and how those things impact it, remember that quite a few mobiles that are in the alert area will already be displaying from the first broadcast. They're not going to be waiting for rebroadcast or for the WAMs. So in many mobiles, this is going to have almost no impact at all. Yes, there are some possible latency issues. I had mentioned earlier that we have the limitation of 100 coordinates specifically to push over the broadcast channel. I do realize that WEEE 2.0 is just now coming into the field, where we're going from 90 characters to 360 in 2 languages. So yes, all of these things will impact the amount of information that we have to broadcast. But we have been looking at those limits. This is part of the reason that we placed a limit on the number of coordinates, was to protect the system. And while this is still undergoing analysis at this time, we believe that the limitations that we have placed will be enough protection for the system, and they will keep us from seeing any significant delays in getting that information out to the mobiles and having the alerts presented.
Okay, excellent. Thank you, Terry. I know that was a long question, so I appreciate you taking that one. One other question that came in, Brian, I think this one is for you, is what are the impacts on 5G to WEEE?
Okay, Steve. Yeah, currently there's no impact on it as, you know, if we look at the current deployments of 5G, they're known as what's non-standalone deployments. And those utilize both 4G LTE as well as 5G base stations and are supported by the LTE core network. So non-standalone deployments don't have any changes to the current standards, and in fact the operation is exactly as described in this presentation, since it's on LTE. Now, there's future development for standalone systems, and that is where you no longer have the LTE core network and the 4G LTE base stations. You just have the 5G new radio as well as the 5G next gen core. In those systems, there is standards work underway, and ANIS is going to assess any impacts as the 3GPP specifications are progressed. And anything beyond that really is for further study.
Okay, great. Thank you, Brian. And I know I've seen a number of questions coming in regarding sort of the implementation and what the devices will be and what they can do, and a number of those types of questions coming in. Those questions are outside the scope of this particular webinar. A lot of those are vendor and carrier specific answers, so we probably won't be able to get to many of those types of questions. But let me see, there's some others. So maybe to Terry, one question is, how long will the device wait for a location fix before deciding to render the alert as a fallback?
Okay, thanks, Steve. This is going to be based on operator policy to a certain extent. Once again, we have the 4 critical specifications that have been published in May, but this particular question actually falls under some of the ongoing work because that's a configurable number on the system. So that means basically that we can go ahead and develop the system itself and then put that number into place later in terms of, you know, are we talking about a number of seconds, particular number of seconds? Also, you know, we have some other aspects of this to look at, like if location is already available in the mobile, should we go ahead and use that? If it's fairly fresh location, that sort of information. So a lot of different aspects to look at there. And I guess the important thing would be that, once again, we know that the alerts are critical in their timing. So we're not going to want to wait very long. And with today's smartphones and location capabilities that they carry, we really should not have to wait very long. So that decision will be based on that critical nature of getting the presentation out and knowing that in today's technology, we should be able to get location quickly. And if we can't get it very quickly, then that means we're probably not getting it. We need to default to presentation.
Okay, great. Thank you, Terry. One other question, are there any requirements for vertical precision? Brian, given that's maybe a requirement on the regulatory side, I'll maybe put that one to you.
Yeah, the answer is no. There isn't on vertical precision.
Okay. One other question, are these standards being used by Canadian wireless operators? We know we've had some participation from a wide array of operators, but I don't personally know if any of those have been implemented. I know they've been interested in the WEEE activities, but I don't know, Brian or Terry, if you know factually if the Canadian carriers have been implementing them.
I don't have any knowledge in that area. Brian?
Yeah, I know there's been some tests of their version of wireless emergency alerts, but yeah, really, I think we probably need to get back and answer that question later, Steve.
Okay, thank you. Sorry, questions are popping in. I'm trying to get to some of these. And I think these we answered. One question is, you mentioned the roving solution will have that impact on battery life. What impact will this have on the batteries? So maybe Terry, that fell into your presentation.
Sure, Steve. I would say, though, this is really a similar answer to my last one, that this is still an ongoing analysis. I do know that companies have been looking at this, and based on just initial numbers, and of course we're based on the fact that we cannot actually run WEEE 3.0 and see the specific impacts from that, we had to associate it with other types of functionality that wake up the mobile regularly and kind of try to make observations there. And based on those observations, came to the conclusion that we really need a more in-depth analysis on this so that we make sure that we are not having too much impact on the battery power, thus impacting the user at a time when they may need to be able to use that mobile to communicate to other family members or emergency responders.
Okay, thank you. And I think this one might be for you as well. If the device-based geofencing cannot be performed, will the amount of overreach or bleed over be the same as today for a given alert?
So my understanding there, if I understand the question correctly, is yes, because what we already had for WEEE 2.0 was the fact that we would broadcast in every cell that's touched by that polygon. So we're still going to be doing that. And if device-based geofencing cannot be performed for whatever reason, then yes, that same, it's going to look just like WEEE 2.0 in the field then.
Okay, maybe just one or two more. I know there's a couple of them that have come in. And I'm not sure to whom to send this one, maybe to Terry. If the user turns off device location settings, E911 can ignore user setting to check device location. Can we, device-based geofencing, ignore the user's location setting off? If it's set to off, I guess that means.
Right. To the best of my knowledge, the FCC has not indicated that we can simply ignore all of the user settings. The difference being that 911 is triggered by the user and considered a call for help. So we were able to bypass those settings to get location. WEEE is a different situation. So there may be some future policy decisions on that, but to the best of my knowledge, if the location is completely turned off in the phone, we do not have a way to get around that.
Okay. Sorry, I'm trying to look through all the rest of the questions that have come in. One question, I think this probably we have time for one last question, which is, an alert can be efficiently described using 1 or 2 dozen circles. Is there any desire to allow multiple circles in lieu of the 10-shape limit? And I think Terry lost audio. Brian, I don't know if you can take a stab at that one, or we should take that one offline.
Yeah, I think that one probably offline, because it's going to be a probably in-depth, more in-depth answer that's going to be required for it. But I think the question was, can you use multiple, numbers of circles instead of a polygon with, up to 100 coordinates or so forth. So there's trade-offs, I think, that would have to be made. So let's take that one offline, and I think we can get back with an answer on that.
Okay, great, thank you. And I believe Terry is back. With that, I know there are some other comments or some other questions that we won't have a chance to get to right now. Thank you, everybody, for participating and for your questions and comments. In closing, I'd just like to thank Brian and Terry again for the presentations, providing the background details about WEEE 3.0. We may hold future webinars on WEEE activities as we continue to progress these and other activities. I'd also like to remind everybody that the slides from today's webinar will be distributed in the near future, and we will also announce any future webinars by email as we did recently. On behalf of Addis, thank you again for attending today's webinar, and enjoy the rest of your day. Thank you.